well, we shall see. So here we go. We were on letter F, technically. E, that's right. So what did you guys do as your verbal? Oh man, I'm going to mess up my color coding. So it's red and then it's green and then blue. Down, I agree. Down 3. Which means what's changing? My X's or my Y's?
Y.
Okay, so instead of being at -4, 2, isn't it going to be at -4, -1? Right? This one's going to go down 3 to be at -5. At -5. And at -1. Did anything else change besides the shift down?
No.
All right, guys. In chapel, we give a lot of grace, but in class, it is in my domain. We do not talk when the teacher's talking. Do we understand? And we should think about whether or not we're talking when the speaker's talking if it's not something that is applicable to what they're doing. If they're making a joke with you and they're trying to have you think about something with your friends around you, yes, we understand. You're going to have a huge reaction. But then you show respect to your client. Thank you. Okay. It was just shift down, a simple shift down. It was a rigid transformation because nothing else changed. Did rigid show up in homework? Was it you guys that started? Is that a book? No, rigid wasn't. Okay. I didn't remember. What's going on in letter F? Okay, here's the struggle. You just said 2 different transformations. Which one goes first? We thought through this and it didn't matter, so we just went for it. What I heard a second ago was reflection and then a shift. So that's what I would write down, but I need you guys to think through with me. Will this make a difference? No. Think of the original graph. The original graph are these 4 points, right? It was weird. They didn't give me like an actual equation or function. They just gave me a graph. Okay, so if I vertically flip it and then go down 1, or if I go down 1 and then vertically flip it, will there be a difference? Yeah. Do you see it? If I flip, right now it's upside down and it ends here, right? If I flip and then shift. If I shift and then flip, do you see it? It's going to be totally different. Well, no, but that's the point. Like, the order matters. Yesterday it didn't matter at all, but today if I flip and down, it ends down here. But if I shift and then flip, it ends up here. So what's the right way? You guys were totally right. It was a flip. But we have to keep an eye open. You're okay. We have to keep an eye open on which is the appropriate. Now, in these ones, it's really hard. Because in these ones, you don't have like a normal function. A normal function, we could plug in a point and make sure it works on where we landed and we're okay. But in this one, it's kind of like, I don't know what the function is, so I just have to do what I think is right and go for it. What's going to happen if we vertically flip and shift down? We know where we're supposed to land, but how do we do it point by point? What's going to change with this guy? What do I do first to the y's?
Multiply by 1.
Multiply by a negative. And then, aren't these both vertical changes? So the x's are staying completely the same. If I flip and then shift, the x's, it hasn't gone right or left at all. So I'm only dealing with the y's. It's an outside and an outside, a multiplication of a negative outside and a minus outside. So the y's need to flip sign and then subtract 1. So if I flip sign, wouldn't that be a -2? And a -2 minus 1, wouldn't that be a -3? This one ends up down here because it's going to flip to a -2 and then go down. This one's going to flip to a +2 and then go down 1. So times a negative and then -1 times a negative, +2, then -1. So I'm doing these changes point by point. Multiply by a negative, -2 minus 1 is -3. And I end up with it not only flipped, but it also shifted down. Are we okay? Now if you think about it, if you think of this just being a y, and you were to plug in a y, wouldn't you have multiplied by a negative, then subtracted, PEMDAS? Wouldn't you have done multiplication, then subtraction? Maybe that's why it's the order that it is. So let's check this one. If we were to do PEMDAS, if we were to plug in an x, the changes are happening to the x and then to the y, what order would we do? If we were doing PEMDAS, would we have flipped it and then shifted, or would we have shifted and then flipped?
Shifted.
So we wrote it this way because it didn't make a difference, but maybe it should have gone the other way. Technically, in a case where it would have made a difference. Okay, last one. Technically, it should be red if I'm doing my cool color coding. So I'm going to do red instead. I already wrote down yesterday, horizontal dilation. Why am I saying it's horizontal? On the inside. Why am I saying dilation?
Because there's a number.
There's a number being multiplied, not added, not subtracted, not with a negative. True? And why did I put by 1?
Because 2 is
always weird, and it's not a 2, it's a reciprocal 1 over 2. So some of you were saying shrink. You're totally right. Why is it a shrink? Because it's happening in half the time as you double the speed. That's the best way for me to show it right now. In a sense, you're doubling the speed, so it's happening in half the time. So as a result, oh wow, he's way too messy. Oh, I don't have another one though, do I? All right, it's okay, we'll figure it out. What if I was to make it into yellow? It's going to be awkward, but that's all right. Oh, okay. So if I do yellow. How do I do a horizontal dilation by 1/2? We know it shrinks. But mathematically, how do I get the perfect point? Divide everything. Careful, not everything. But what's Sid saying? Who do I need to divide?
the x.
The x is because it's horizontal. So I need to take every single x and divide by
1/2.
Divide by 2 or multiply by 1/2. Same thing. So what's -4 divided by 2? -2. The y stays the same. X is now -2. What's -2 divided by 2? -1. I'll pretend that's over that way a little bit. What's 0 divided by 2? 0. And what's 6 divided by 2? 3. There we go. Horizontal shrink. Horizontal dilation by a factor. How are we doing, guys? Did I lose anybody? Say. I don't mind you saying horizontal shrink, like in letter G. Here's the struggle. Do you guys know how in English you're not supposed to use double negative? Can you give me an example of what a double negative would be in English, like something that you're not supposed to do when you're writing?
You can't not use double negatives.
You can't not use double negatives. There you go. Which means you actually can. Because like in math, a negative times a negative is a positive. It's kind of the same in English. If you can't not do something, oh, you can do it. So when you say horizontal shrink, my question would be, how would you finish that sentence? By? You would have to say horizontal shrink by 2 because you're shrinking. And you're shrinking it, dividing it by 2. The awkward part is, I want you to remember that you're multiplying all the x's by. So if you were to say horizontal shrink by 1/2, technically, you're stretching it. Does that make sense? So I just say horizontal dilation by, so I can fill in whatever the proper number is that I'm multiplying the x by. That way I'm safer. I can say horizontal dilation by 1/2, aka it's a shrink. I mean, I wouldn't write aka, but it is a shrink. You're right. Just be careful of what you put after you use the word shrink. Exactly. So now that we've been through number 9, number 10, how'd it go? I'm not saying absolutely everyone in here did it. I mean, it'd be nice. Algebra 1 for the first time all year had 100% did their homework today. We started it together in class yesterday, but still, we finished it. That's good. First time all year. Oh, I had a whole graph at the bottom. Oh, I should have kept using it. That's okay. Sorry, you guys might have not used all 3. But for those of you that did start homework last night, was there that much of a difference on number 10? Not really, right? Because number 10, he's here somewhere. He's awkwardly here. Oh, he's right here. Here we go. Number 10, I had someone ask me this at the beginning of class, and that's kind of the point as to why we took so much time on number 9. Someone asked me, I didn't write down the function. What's the function again? Oh, yeah. They didn't give you a function. The function is just named f of x, and who is he? This guy. Yeah. They just gave you points and said, well, do what you're supposed to do to the points. In a sense, to be honest, they made it easier. But for most of you, it seemed harder. Why did they make it easier? What happens later on in homework? What are they giving you now? Okay, they're still giving you some graphs. They're still having you do some things. But eventually, where does homework go? No graphs. So how are you supposed to do something crazy like well, actually 28 is not that bad if you remember the HK vertex form of a parabola. We haven't reviewed it yet this year. I just wrote it down. Maybe we should do something more like this one. Here we go. Number 37. We're still in our notes. Say an example. We're going to do an example like the second part of homework. We're going to do an example when they don't give you points, which I know. Some of you guys were like, ugh, the whole giving points thing was so tedious, so annoying. But let me show you number 37. It actually was building up to, even though some people would say it's the hardest part of homework. Come on. It was actually building up to these ones that you're more familiar with as far as how they look. But I'm not totally confident that you're familiar with how to do them. So, what if I was to give you, we have examples somewhere. Let's say we didn't have a graph. Let's say we just had a function. The following. I want you to say in words what's happening. I want you to say in words what's happening. Up 8 and? Left 4 and?
X-axis 4.
And I'm not entirely sure I agree with your order.
Yeah, it's not the right order.
But, okay, so we're going to have to think through them. But there is an up 8 and there is a left 4 and there is a vertical flip, right? Negative on the outside. But what are we between the up 8 and the left 4 and the negative vertical flip 2? Who's my parent function?
Absolute value of x.
So my parent. How are you guys going to start graphing? Oh, V. Like you actually think about who this dude is?
Yeah.
Oh, okay, that's a good idea. So V.
Look at first.
How would you do like a horizontal stretch or compress or vertical stretch or shrink?
There's none. There's no stretch.
But I know, but how would you? You don't have any points marked. Like, what do you? How are you going to do it? It's not easy. I would say that. Eating it is like throwing it away. Why don't we do some points? Right? Can't we do some points? Can't every parent graph technically have a few like representative points that we use? Technically, right? If I plug in 1, positive 1, plug in 2, positive 2, plug in negative 1, positive 1, plug in negative 2, positive 2. Technically, any parent function, I can get a few representative points is what we call them, and just use them. Now could I accurately do any sort of stretch or compress or shrink that I need? Yeah. Why am I showing you this? This one, okay, you're just flipping and you're shifting. I get it, and you could probably do a fairly good picture and be like, yeah, I mean, I don't know, guess, but sure. But I want you to be able to do this precisely, and to do it precisely, especially when we start having dilations, you need to have a few points. Okay, now that we have points, hey, like number 9, like number 10, now we can do our transformations. Because you can think about it as 0, 0, 1, 1, 2, 2, and shift the x's, or shift the y's, or flip the y's, right? Now, Nathan, you said flip first. Why?
I don't know. This is what's easiest for me.
Because it's multiplication? What about grouping symbols? Doesn't parentheses go before multiplication? Is it going to be the same either way? Nathan's thinking ahead. If we shift left 4 and then flip, or if we flip and then shift left 4, is there a problem? Oh, so what's the only problem? The only problem is when we have 2 vertical changes. What should we do? Flip and then up, or do we up and then flip? Okay, so the nice thing is, to be honest, we're doing transformations, you don't necessarily need to have a particular order for everything, but when you have multiple vertical or multiple horizontal, you just need to go the right way. So whether you did a vertical flip, then a left 4, then an up 8, it wouldn't be any different than if you had gone left 4, vertical flip, then up 8. The long story short is who's the very last guy? The up 8. So whatever direction you go, it's not going to make a huge difference. Okay. So we could vertically flip it, and if I were you, I would just do like quick, 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 quick. But why am I not making it solid?
It's not ready yet.
It's not ready yet, exactly. It's not ready yet. Go left 4. So 1, 2, 3, 4. Could some of you do multiple ones of these at the same time? Yes. If I was showing the step-by-step progression, what I just did. Something about it. I need more space, because what am I supposed to do in a second?
Move it up 8.
Go up 8. So 1, 2, 3, 4. Okay. So this one's going to go left, 1, 2, 3, 4, and then up 8. There he is. And then this guy's going to go left 4, and then up 8, which is actually going to have it be 7, right? And that guy is going to be symmetric. Symmetry is a great thing, because symmetry, if you see that there's 1 point on one side and 1 point on the other, if you place one, you can place the other, as long as there's not a weird stretching or compressing. Same thing with the 2s. If I can get this one on the left, I can get the one on the right using symmetry. So I go left 2, down 2. And go over. And go up and then down. There we go. If you're doing this in your homework, might it not be good to have some sort of color coding issue where you have, I don't know, there's the original function. I think they even tell you to graph the parent function. I don't remember exactly. And then graph the transform function. You definitely color code, that's okay. But in homework, there's something else that might confuse you. Depends on the section, it depends on what the directions are, but there's something that says rewrite or write the transform function in function notation. Did anybody see that yet? Nope, didn't get that far. Well, function notation. It's going to be weird because you're like, it's right there, it's function notation, g of x of color. But that's not what they mean. They mean as soon as you identify that f of x is absolute value of x, how do we take out the absolute value and put in the f? How would we rewrite this function where g is in terms of f, not absolute value? How would it look? And so I'm going over it because I was worried in homework you guys would do the exact same thing. So, does this make sense? Does it work? If f of x is the absolute value, is this the exact same thing as that? Because I'm adding the 8 on the outside of the function, I'm adding a 4 on the inside of the function, and I'm multiplying by a negative on the outside of the function. If they're asking you for function notation, they're saying, think about who the parent function is, name him f, and then rewrite in terms of f. Kind of makes sense? No, it's going to confuse you. Guys, let's go check out really quickly if there's anything else in homework that we need to talk about. It seems like you guys barely got to 10. Maybe didn't even get past it. Let me see if there's anything else huge that we need to cover. Because I was totally going to be like, hey, any homework questions? But so far, no one's actually really been talking like they did go past 10. I'm not saying you didn't. I just haven't heard you. You're writing some equations. You're going backwards in some of these. Like in number 13, you're going to say what changed to get to here or what changed to get to here. There have been some transformations. So there's going to be some going backwards. There's going to be some going backwards in things like these, and then there's going to be some words. To be honest, I think the word ones are kind of the easiest ones.
Yeah.
The function ones are probably the next harder. But for just a few of you, I'm a little worried about something like number 17. Can we do one last example? What if I was to give you something like number 17? Yeah, y equals, that's cool. Are you sure? Were there any other transformations, or were there not? So let's check it out. What if we were to have number 17? The directions are identify the parent function. Nathan just said y equals negative x squared. So what does he think the parent function is for number 17? An x squared one, right? And then figure out what changed to get the graph, and then write an equation. Yeah? Okay, so that's our goal. According to Nathan, the only change that happened was a flip down. What do you guys think? Yes or no? Yeah? How do you know for sure it was only a flip down? Couldn't there have been a little bit of a stretch? What do we have to check? Parent function. Let's not do y. We're smarter than that, right? We have f notation, so f can be x squared, and g can be our transform degree, yeah? Okay. Parent functions, think about him. What are his representative points? What are some important points on a parabola?
The origin.
0, 0. I heard just now 1, 1. What else? Okay, that's great. What else? Because that one's just symmetry, right? That's easy.
2, 2, 3, 3.
Why isn't it? I heard a lot of 3s. I don't know if there was a 3. Isn't there a 0, 0, 1, 1, and then 2, 4? Yeah, because I'm, squares. But yeah. So 3 would be 9, 4 would be 16, 5 would be 25, right? And then we can use symmetry to get to the other side. That's not a big deal. How can we prove that Nathan is right? What do you guys see in this graph down here? Do you see -1, -1?
Yeah.
And -2, -4? Approximately. Could there be like a decimal or something that's off? I suppose. But why am I showing you this? Okay, in this one, we can say that g of x is just negative x squared, and x squared that's been flipped down. If we're doing function notation, we could do negative f of x. Our words would be a vertical flip, or better, if we do a reflection in the x-axis. I like about instead of in, but that's good. But to be honest, I'm preparing you for a test question, or a quiz question. What if I was to give you something like, well, let's keep it basic. Let's do the exact same one. But let's instead have -2b. Now, not -2, -4, it's -2, -5. There had to be a dilation of some sort, right? There had to be, because it was, the parent function, if you just flipped it down, wouldn't it have been at -2, -4? So what happened?
Stretch.
A baby stretched up. How do we find stretch? Tell me what you know.
It's supposed to be -4.
Supposed to be a negative. Negative what?
X squared.
Why am I leaving an awkward space?
There's going to be a vertical
Don't we need to solve for whatever that dilation is?
vertical.
So we put in the variable and we say, well, we don't know what the dilation is. If I had made this -8, you would have been like, meh, you multiplied by 2. So I made it -5, so you'd have to actually do math. So how do we actually do math? Can't be a plug-in. We know an x, we know a y. Why not plug them in and figure out the dilation? Now, some of you maybe can do the mental math for it. But I knew there had to be a stretch, because if I had just done a normal -x squared, I would have been at -2, -4. It got stretched just a little bit. So I threw in a variable to say, well, I don't know the stretch, but I know it got stretched. And then we can go ahead and divide by a -8, and I'm coming to you. Divide by a negative, divide by, I did -2 squared is 4. That's my dilation.
1.25.
5/4 or 1.25. So what's my final equation? G of x equals negative 5/4 x. Got to keep an eye to see if there was a dilation. You can't always see it quite easily.
Why are we using the word dilation?
Because technically, a vertical stretch could have been a horizontal shrink. So I just like to use the word dilation because I'm like, I don't know if this was above 1 or below 1. Now, most of us saw that it went beyond, so I could have started using stretch. I just get used to using dilation. Like translation, it just works, whether you're going right, left, or up, down. Dilation works whether you're stretching or shrinking. Yes, the only dilemma is, once again, like what Sid said, if you say if you're saying shrink and you're saying it by a fraction, it's technically a doublement. Okay. With this, kiddos, I think we're good on section 1.7 homework that's due tomorrow. But if you notice, what else is on the backboard for us to do today?
Start at 1.8.
Not just finish 1.7, but also start 1.8. But don't worry, it's going to be the easy stuff. Easy in that there's no graphic. Not much graphic. Easy in that there's no graphic. Not much graphic. Easy in that the math is easy. Because I'm going to fill in blanks with, ready? Plus, minus, times, goodbye. Going back to our simple operations. Hard today because of notation. Hard tomorrow because of concepts. Hard today, just notation. Well, hard today notation, and some of you guys, you never just give up. Sometimes you keep going when you should have just stopped. Today is going to get some of you in trouble. I should say, in section 1.8 homework. It's going to get some of you in trouble. Let me let you get this set up, and then let me show you the two big watch outs, and then we'll do some examples to see if they trick you or not. But section 1.7 homework to tomorrow, section 1.8 will start. We'll be finishing tomorrow. Does anybody see anything as you're writing down these formulas that might describe why I'm saying that notation might be tricky? What do you guys see as you're writing this down? Why I might be saying that notation is tricky? Or no one sees it? Why am I saying notation might be tricky? Is no one brave enough, or does no one see it? I'm still listening for an answer. P.S. I think it scared you guys too much because I was stern, but it was because I needed to be. Remember, I don't mind if you're multitasking and talking. It's just when I start teaching, that's when you're supposed to speak. But now I am talking again, sorry. Anybody see why I'm saying notation, not pitch? Yeah, there is a little thing at the bottom. That's kind of more the math. The math might get tricky when you divide. The bottom can't be 0. It's like a, uh-oh, watch out. So that's the place for the math to get tricky. If we divide 2 guys, we might have a domain problem. But why do they say notation might get tricky? Do you remember yesterday we were working on test corrections? And some of you didn't like this dude? Can I show you what some people did? What mistake they made, and then see if you can figure out why I'm saying notation is tricky? Can we just take this guy as an example real fast? I showed it on the board yesterday. It was up there at the front. What some people did is they said, who is F? He's 5x minus x squared in one of the versions. Oh, yay, I can do math. Dun, 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 dun. Let's foil. Dun, 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 dun. Actually, they didn't foil. They just got scared and stopped. But I saw some people who wrote this down just for this part. How did the notation confuse them? They weren't ready for the notation. Mickey.
They thought that F was being multiplied, but it just means y.
They thought that it was times. And they said, who is F? There he is. Who's that? There he is. Times. I've done times before. It's called foiling. But were they right? No, because it's not F times, right? What was it supposed to be? F of. It's function notation. So all of that was wrong. You had to take this argument and input it into F. So check out the front board. Where are people going to get confused? They're going to think times x. But guess what it's not? The very thing it isn't. That's the very thing that your brain's going to want to do because you've been multiplying a lot longer than you've been foiling. So every time you see this notation, why am I giving you these formulas? Some of you are like, okay, duh, 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 but it's because this notation is tricky. So I'm going to say careful of the notation. And the reason I'm saying careful is because it's not times. So when I give you examples on the next page, and if you see F plus G, I need you to say of X, right? Or when you see F minus G, I need you to say and think of X. Or F times G of X, F over G of X. And you have to realize that of is not times. The notation thing is a tricky thing. It'll mess people up. So let's see if it messes you up. Except, can I change this just a little bit? Because the one other, I think there were 2 common mistakes in this portion of section 1.8. What if I change this to be e to the x? I'm going to change it to be e to the x. I know we haven't done ln's, we haven't done these, but make it e to the x instead. I think it's going to kind of show what my point is. I'll put it in black so it makes a little more sense. Make it 2x plus e to the x, and then x squared plus 2x minus 1 for the other one. What is it asking you to find? Good. See it? The sum of f and g of x, or f plus g of x. And everybody could have answered that, because isn't there a word find, and you just read me what's next? Okay. So it's f plus g what? Of x. So the very first thing when you see this notation is to remind yourself what this actually means, because your brain is very naturally going to get it confused. And now, oh, okay, I'm just adding those 2. Who are they? Well, there's that guy. And there's that guy. Question. It was very dangerous, but it was okay this time. What did I not put in? probably should have, right? Who's f of x? Who's g of x? A big old plus in between. Why was it legal, since I'm a lazy mathematician, if I don't have to do something, I won't? Why was it legal when I didn't have those? When there's nothing in front, no extra coefficient or no negative sign, if I distribute a positive 1, nothing changes, right? So technically, the first step, if you did show your parentheses, would just be to rewrite everything, because distributing a positive 1 makes no changes. But what are you supposed to do next?
First you simplify.
I would say simplify, like an understood direction. But yeah. It's asking you to plug in 3 soon. So guys, this time I am going to go ahead and put that x squared, then put that 4x, and then put that 1, and then I'm just going to throw e to the x at the end. What's the only reason I rewrote? Because 2x and 2x are like terms, right? But did I combine the e to the x with anybody?
No.
Or the x squared with anybody? Or the 1 with anybody? You only combine like terms. So if all of them were different, would I have combined? If all of them were different, were not like, would I have combined? Nothing. Some of you that are like, no, you have to do something, just be careful. You're going to make mistakes. Okay, but then once we have that, then I need to do f plus g of 3. It's even harder to tell your brain of 3 and not times 3. Be careful, I'm warning you, I see it time and time again. But is this one legal way to do it?
This joke, it's minus 1, not plus 1.
Oh, I rewrote it wrong. Is it legal just to take the equation that we found up above and just to plug in, guys?
Yes.
Mm-hmm. But is there another way of doing it?
Yeah. Oh,
Alright, we'll see tomorrow if that other way confuses you or if you guys are golden on top of it. 1.7 is the objective. Right, but if you start 1.2, I would be proud.
You're leaving.
I'm not leaving you, I'm just leaving. You just suck.